Hey everyone, Miss Ross here with Mrs. Ross Does Math. Today I'm going over the Math 8 Unit 7 review. We just finished up this unit last week, and now we're getting ready for our test. So you'll have the review to complete this week and our test next week. Now the review is a little bit long, so I would highly recommend splitting it up into 2 days. This way, you don't get some brain fatigue, and if you're getting frustrated, you give yourself a little bit of time in between. Let's get this going. So for part 1 of our review, we have some multiple choice, and let's get it started. So number 1 says, what is the value of the square root of 36? Well, the same number that multiplies the other to give me 36 is 6, so that means that B, 6, is my answer. Next, a square has an area of 100 square inches. What is the length of one side of the square? Well, when we talk about the area of a figure, we talk about it being length times width. Now, we don't know what our length is. It's asking us for that. Now, if we're talking about a square, its sides are all congruent. They're all equal. So whatever x is here as my length, my width is also going to be the same. So instead of length times width, I'm going to have x times x. So here we'll have 100 is equals to x times x. X times x is x squared. So 100 equals x squared. Now I'm going to square root both items, leaving me with x is equals to 10. That tells us that our answer is A, 10 inches. Number 3. Now this is an area that several of you struggled with. I believe this was in lesson 14 or lesson 15. And when we talk about what two integers does the square root of 54 fall between, we talk about when it is simplified. What small two numbers does it fall between? Yes, 54 falls between 53 and 55, but here we're talking about the square root. So when we talk about the square root of 54, it's not going to be between 53 and 55. So we're going to cancel that one out. Now there are two square roots that have a perfect square that 54 falls between, and that is 49 and 64. The square root of 49 is 7, and the square root of 64 is 8. So what two integers does the square root of 54 fall between? 7 and 8. Our answer is C. Next, we have what is the approximate value of the square root of 30 to the nearest tenth? Well, we know here that we're approximating, so we're going to do what we can. The square root of 30 is somewhere in between the square root of 25 and the square root of 36. Square root of 25 is 5, and the square root of 36 is 6. So we know that it's not going to be 10 or 15. So we can cross those out. Now 30 is 5 away from 25 and 6 away from 36. So honestly, I will accept either A or B. When we're rounding here, it's going to go ahead and give us 5.5. But I will truly accept either 5.4 or 5.5. Either one of those will work. It's too big of a comparison. Now, if we had 5.5 and 5.7, that would be too far off, so then yes, our answer would only be 5.5. But when we actually find out what the square root of 30 is, the square root of 30 is 5.47. When we would round, that 7 would make this become a 5. So I will accept either one. Okay. Next, looking at number 5. What is the length of the hypotenuse in the triangle? Remember, the hypotenuse is our C. Excuse me. It is always across from our right angle. So let's label our pieces. We have A, we have B, and we have C. When we want to find the hypotenuse, we're going to use a squared plus b squared equals c squared. A is 8, so I'm going to plug that in. B is 15, so I'm going to plug that in. And C, don't quite know yet. 8 squared is 8 times 8, which is going to give me 64. 15 squared is going to give me 225. And adding those two numbers together will give me 289. Now I have c squared. What I want to do now is just square root both my c squared and the 289. And when we do that, we get 17. So that tells us that B is our answer. Next, 6. What is the value of x rounded to the nearest tenth if necessary? Again, we need to go through and identify our pieces. This is my C, meaning that x and 3 are my A and my B. I'm still going to use Pythagorean Theorem, a squared plus b squared equals c squared, but now instead of a number for A, I'm going to put x, I'm going to put 3 for B, and I'm going to put 7 for C. That's why it really helps us to identify the pieces of our problem first. Now I'm going to leave this as x squared. Then I'm going to go 3 squared, which is 9, equals 49, because that's what 7 squared is. I'm going to minus the 9 from both sides, giving me x squared is equals to 40, and I'm going to find the square root of each. Now the square root of 40 is going to be 6.32. And then because it tells us in the directions round to the nearest tenth if necessary, our answer is going to be approximately 6.3. That leaves us with C as our answer. Next, which of the following are not the side lengths of a right triangle? Well, for this, we want to make sure that what we have is a set of perfect squares. So, 3 squared plus 4 squared equals 5 squared. That's how we'll plug this in. We get 9 plus 16 equals 25. 25 equals 25. Yeah, A is a possibility. Next, 5, 12, and 13. So I'm going to go 5 squared plus 12 squared equals 13 squared. I get 25 plus 144 equals 169. I get 169 equals 169. So far, that one's good. Next, C. We're going to go 7 squared plus 24 squared equals 25 squared. 7 squared is 49 plus 24 squared, which is 576, equals 25 squared. Now 49 plus 576 does give us 625. Now that means that because the first 3 were, it would be safe to assume that D would not be. However, we need to prove that mathematically. So I'm going to go 6 squared plus 8 squared equals 12 squared. I get 36 plus 64 equals 144. And I get 100 equals 144. That does not work, so that means that D is our final answer. Now, once again, we could assume that because the first 3 worked. However, occasionally, especially with the state testing, they'll throw something funky in there, and you still got to prove it mathematically. All right, everyone, so here we go. I forgot to add my name, period, and date, so please make sure that you do that. I am recording today on May 7th. All right, so here we go. So, Seth bikes 3 miles south and then 2 miles west. Approximately how far is Seth from his starting point? So, let's draw a figure. Seth goes 3 miles south, so that's south, and then he goes 2 miles west. From there, how far is Seth from his starting point? So we want to know how far he is. So I had my 3 miles south and my 2 miles west. So here we go. This question mark would be our hypotenuse. So let's set it up. We have 3 squared plus 2 squared equals x squared, because we don't know it. 3 squared is 9. 2 squared is 4. Next we get 13 equals x squared. We're going to square root this. And when we square root this, we are going to get approximately 3.6 as our x, which means that B is our answer. Okay, now number 9 in this review is an extra credit problem. So go ahead and give that one a shot all on your own. It's a bit of a challenge. Next, number 10 says, what is the length of C on the graph below? Well, let's start out by figuring out how high we are. So we go down 1, 2, 3 here, and we go over 1, 2, 3, 4 there. So using Pythagorean Theorem, my A is 3, my B is 4, and my C, I don't know. So we're going to figure that out. 3 squared is 9. 4 squared is 16. Add those two together, you get a lovely 25. Square root them both, so we're going to end up with 5 equals C, which means our answer is A. Next up, number 11. Solving number 11, we are going to be needing to take a look at using the distance formula. The distance formula, once again, is D is equals to this big square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. So let's start labeling everything. x1, y1, x2, y2. Now let's plug this in. So we have D is equals to the square root of x2, which is 4, minus x1, which is 9, squared, plus y2, which is 8, minus y1, which is 2, squared. Now 4 minus 9, that's going to give me negative 5. I'm going to keep that in parentheses squared, plus 8 minus 2, which is 6. And once again, we're also going to keep that in parentheses squared. And we get D equals the square root of negative 5 squared in parentheses plus 6 parentheses squared. Let's solve it. Negative 5 in parentheses squared is going to give us 25, so we get D is equals to the square root of 25 plus C squared, or sorry, not C squared, C squared. 6 squared is 36. Add these two together, you get 61, so I get D is equals to the square root of 61. Square root of 61 is going to give me approximately 7.8. So our answer is C. All right, here we go. Moving on to part 2. Part 2 is our free response. This is where you're really going to get the chance to go ahead and show me everything you have learned. Number 1, A, find the value of each root. And in here, I also gave you guys some clues of where you can find some help. So for number 1, you can look to lesson 14 for help. So square root of 16, that's 4. Square root of 49, that's 7. Square root of 121, that's 11. So 4, 7, 11. Just by chance, they all add up to be 11. Next, number 2. A square base tent covers an area of 64 square feet. What is the length of one side of the tent? Now this problem is very similar to problem 2 in the multiple choice. So I'm going to go, our area is equals to 64 square feet. Area is equals to length times width. We don't know what our length is. We don't know what our width is. So area is equals to length times width. I'm going to plug in the 64 for the area and an x for length and an x for width. X times x gives me x squared. So x squared equals 64. I'm going to square root both, giving me 8 is equals to x. Now here, because this is a word problem, we need words in our answer, especially a unit of measurement, so we're going to say the tent length is 8 feet. There we go. All right, next up. Okay, once again, name, date, class period, please. I'd like you guys to make sure that you put that on each and every page, just in case something gets separated. Whoop. All right, here we go. So, what two integers does the square root of 21 fall between? And I gave you a hint. Think square root of 16 and square root of 21. The square root of 16 is 4. The square root of 25, did I say 21 earlier? I think I meant to say 25. The square root of 25 is 5. So when we talk about what two integers does the square root of 21 fall between, the square root of 21 is going to fall in between 4 and 5. And again, you can seek out lesson 15 for help. Next, use a calculator to approximate each square root, and I want you to round to the nearest tenth. This is something, again, where you can seek out help in lesson 14 and 15. Now, the square root of 7 is going to be approximately 2.64, so it's going to stay as 6. So 2.6 is our answer. The square root of 46 is 6.78. That 8 is going to cause my 7 to round up. So we're going to be left with 6.8 as our answer. And the square root of 150 is 12.24. This 4 is going to cause my 2 to stay the same. So I'm going to have 12.2 as my square root. Next, we're moving into numbers 5 through 7. Once again, you can seek out help in lessons 14 through 15 for this section. Starting out with number 5. We have x squared equals 25. I just want this to be x. So I'm going to square root both sides, leaving me with x is equals to 5. Boom. There's my answer. Next, for number 6, we are going to go ahead and treat this just like we would a two-step problem. That's where we use SAD-MAG. We subtract or add our number away first. We multiply or divide next, and then we do our exponents or our grouping last. In this case, we're going to go ahead and add 7 to both sides, giving us x squared equals 36. I'm going to square root both, giving me x is equals to 6. We get another perfect square. Next, we're going to go ahead and once again use SAD-MAG on number 7. So we're going to begin by subtracting our 3 from both sides, giving us 4x squared equals 44. I'm now going to divide by 4 on both sides, giving me x squared equals 11. And now I'm going to square root both. And the square root of 11 is 3.31, meaning my 1 is going to cause my 3 to be the same, so x equals 3.3. And that is our final answer on number 7. Numbers 8 through 10. We are still finding the value of x in each right triangle, and if necessary, we are going to round to the nearest tenth. If you need help in this section, you can seek out lessons 16 and 17. Here we go. Number 8, we have our hypotenuse. Once again, it's always across from the right angle, so that's going to be our C. A is going to be 5, B is going to be 12. If you want to switch those up and have 12 be A and 5 be B, that's totally fine as well. Here we go. I'm going to go A squared plus B squared equals C squared. We're going to plug in those numbers. 5 squared plus 12 squared equals C squared. 5 squared is 25. 12 squared is 144. Next, adding those two together, we get 169 equals c squared. We're going to square root, and our answer is 13 is going to equal c. So 13 is c or x, whichever one you want to put down. Next up, number 9. Once again, we're solving for the hypotenuse in this case. So we have A, we have B, we have C. Here we go. 3 squared plus 8 squared equals x squared. I'm going to use x this time instead of c because that's the variable that it's asking for. I'm going to go 9 plus 64 equals x squared. That's going to leave me with 73 equals x squared. Watch that addition there. Make sure that you're actually doing 9 plus 64. And the square root of 73 is going to give us 8.54. Now we need to round to the nearest tenth. So I'm going to take a look at this 4, and that's going to cause my 5 to stay the same. So my final answer is 8.5 is equals to x. Now on number 10, it's asking us to find not the hypotenuse, but a side length. So this is my C, and then I can have this be my A, and that be my B. Here we go. I'm still going to use a squared plus b squared equals c squared. We're still using the Pythagorean Theorem. But instead of plugging something in for A and B, I'm plugging something in for B and C. So I'm going to have x be my A, my 6 be my B, and the 8 is my C. Now I'm going to keep this as x squared plus 36 equals 64. I'm going to minus 36 on both sides. And when I do that, I'm going to be left with 28, I do believe. I'm having a little bit of a brain fart here. Yes, 28. So we're going to get x squared equals 28. We're going to square root on both sides, giving us x is equals to 5.29. Now this 9 is going to cause my 2 to increase. So we get x equals 5.3 as our final answer on number 10. Now if you need a moment, please pause this video, go back through, rewatch any of it. If I'm going too fast, you got a pause button. Use it. Here we go. Next up, number 11. In numbers 11 through 12, once again, you are still using lessons 16 and 17. That's why I did not put any new thing here. So if you need more help, go back and look at lesson 16 and 17. Taking a look at these, in 11, we are being asked to determine if each set of given lengths forms a right triangle. So we're going to plug these numbers in. That's my A, that's my B, that's my C. 3 squared plus 4 squared equals 5 squared. 3 squared is 9. 4 squared, 16. 5 squared, 25. 9 plus 6, we do get 25. So 25 equals 25. We are going to put yes as our answer. On B, we have 2.0, 2.1, 2.9. So once again, A, B, and C. Now 2.0, that's the same thing as 2. So I'm going to leave it as 2.0 just because that's what it's in the problem, but it's just the same as 2. Next, I got 2.1 squared, and I have 2.9 squared. So 2.0 squared is going to give me 4. 2.1 squared is going to give me 4.41. And 2.9 squared is going to give me 8.41. 4.41 plus 4 is going to give me 8.41, and that is the same as 8.41. So once again, our answer is yes. Lastly, on C, once again, we have A, B, and C. So we have 5 squared plus 7 squared equals 9 squared. 5 squared, 25. 7 squared, 49. 9 squared, 81. Here we're going to get 74 when we go 25 plus 49, and that's going to equal 81. In this case, that does not work, so we're going to put a slash through our equal sign, and we are going to write no. Next, number 12. It says, which of the three sets of numbers in number 11 make a Pythagorean triple? Explain why. Well, in here, in number 11, which of the three sets? We have A and B. So A and B are the sets of numbers that make a Pythagorean triple. Next, I want you to explain the why. So we've identified what three sets. Now you tell me the why. All right, moving on. Number 13. For number 13, 14, and 15, they are all using the same directions, and you can seek out help in lesson 18. That's why I cued that in there. Here we go. Laura has a 12-foot ladder. The safety instructions recommend that she should have the base of the ladder 4 feet from the base of the wall, meaning the ladder needs to be at an angle 4 feet away from the wall. Our question is, how high will the ladder be able to reach the wall? So even though the ladder is 12 feet, ladders, they don't just hang directly against a wall. They hang diagonally against the wall to provide stability. So my ladder is going to be at a diagonal. And my ladder is 12 feet. Now, my ladder needs to be 4 feet away from the wall. So 4 feet away from the wall. What I'm asked to find is where on the wall will the ladder hit. So that means here I have an X. So how high will the ladder be on the wall? That's what we're being asked to find. So here we go. I have my A, I've got my B, I've got my C. Why is the ladder my C? Because it is at the diagonal. So I'm going to go x squared plus 4 squared equals 12 squared. X is the height of the wall where the ladder will hit. So x squared plus 16 equals 144. And a minus 16 from both sides, leaving me with x squared equals 128. And I'm going to square root both. Now when I do that, I'm going to be left with 11.31. Oop, did not mean to have that up there. So x equals 11.31. Now the directions state to round to the nearest tenth. So we're going to leave this as x equals 11.3. Now, because this is a word problem, we need words in our answer. So we're going to state the ladder will hit 11.3 feet high on the wall. Okay, so the ladder will hit 11.3 feet high on the wall. And that's it for number 13. Moving on, we've got number 14. Number 14 says, Kenny leaves home, walks 10 blocks east, 24 blocks north to get to the movie theater. How far is the movie theater from Kenny's home if he were to take a direct path? Now, in large cities like that of Eugene, Seattle, yes, I know I just compared Eugene to Seattle, and many others, you have the ability to walk to go to a movie theater. Now, when we talk about distances, instead of it being in miles, we talk about blocks, or how many streets are we going to have to go through. So, we're going to do that here. So, Kenny leaves home and walks 10 blocks east. Okay, so Kenny walks east. Then, Whoop. Sorry about that. Wrong place to put that. Alright, so Kenny walks east. 10 blocks. Then he walks 24 blocks north. Okay. So our question is, if Kenny were to take a direct path, because here's Kenny's home, and if he were to go directly from his home to the movie theater in that direct path, how far would he travel? So, looking at this, we have our right triangle once again. We have 10, we have 24, we have an unknown. Let's use Pythagorean Theorem. So, 24 I'm going to put down as my A. 10 I'm going to put down as my B. The distance directly from Kenny's home to the movie theater is my unknown. 24 squared is 576. Plus 10 squared, which is 100. Add those two numbers together, you get 676. And 676 square rooted gives us 26. So 26 equals x. So once again, we need words in our answer. So we would state, if Kenny walked in a direct path to the movie theater, he would go 26 blocks. Boom. There's our answer. Next, number 15. That is also extra credit. So in part 2 of this review, you have not only you got number 9 on the as extra credit in the multiple choice, and you have number 15 as extra credit in the short answer, part 2. Moving forward. Number 16 and 17. 16 and 17 says, use the points and find the distance between each set of points. When necessary, round to the nearest tenth. Now, to solve these, you can either use Pythagorean Theorem or the distance formula to solve. Be very, very careful as you are plotting these. That is going to be a potential hiccup if you get something wrong. It's probably because the coordinate point wasn't plotted correctly. So pay attention to that. Here we go. I have -1, -3. So -1 is my x, -3 on my y. My point is right here. And 2, 1. So I'm going to go over 2 on my x, up 1 on my y. Now I'm going to draw my line connecting those together. Now you can either create a triangle vertically or you can do a triangle down. I'm just going to go ahead and do one down. Okay. So from here I go down. I'm going to switch markers this time. 1, 2, 3, 4. So I have 4 on my vertical, and I have 1, 2, 3 on my horizontal. So 3 squared plus 4 squared equals my diagonal, which is C. 3 squared is 9, 4 squared is 16, equals C squared. I'm going to get 25 equals C squared, and square rooting it, we get 5 is equals to C. So our answer for number 16 is 5. Next, number 17. We have 0 for our x, 4 for the y. So I'm at 0, 4, which is right on the y-axis. Next, I have 4 on my x, -3 on my y. So I'm all the way down here. Excuse me. I'm going to connect those diagonally. Now once again, I'm going to create my graph, or not my graph, my triangle, using those dotted lines. So I go down 4, and then 5, 6, 7. So my vertical is 7. My horizontal is 1, 2, 3, 4. So I have 7 for my A, 4 for my B, or, sorry, 4 for the A, 7 for the B. Technically, the 4, because it's the horizontal, that should be your A, while the 7 should be the B, because it's the vertical. It's the Y. So, here we go. So, 4 squared plus 7 squared equals C squared, because we want to find the diagonal. 16 plus 49 equals C squared. I add those two together and we get 65 equals C squared. Next, I'm going to square root both sides, and 65 squared, or the square root of 65 is going to be 8.06. And we need to round to the nearest tenth if needed. So the 6 is going to cause my 0 to increase, leaving me with a final answer of 8.1 is equals to C. Okay. Now, we only have 2 more problems left, so hold on just a moment. We're almost done. Hang in there with me. And here we go. Looking at number 18. Okay, it says use the distance formula to find the distance between each pair of points. If necessary, round to the nearest tenth. You're going to use lesson 20 for help on this. Okay, now before we start out, I'm going to put the distance formula up here. Now, distance is equals to the square root of x2 minus x1 squared plus the difference of y2 minus y1 squared. So, first off, let's label. I have my x1, y1, x2, y2. x1, y1, x2, y2. Now, we're going to make sure that we plug these numbers in correctly. Here we go. For 18, I have 1, 7, and 3, 9. So, x2 is 3. x1 is 1. So, 3 minus 1 squared. Now, plus y2, which is 9, minus y1, which is 7. So, 9 minus 7 squared. Now, I have the distance is equals to the square root of 3 minus 1, which is 2, plus 9 minus 7, which is 2. Now, I'm going to find out what 2 parentheses squared is. So I have d is equals to the square root of 4 plus 4, because the square 2 squared is 4. So 4 plus 4. Now, 4 plus 4 happens to be 8, so d equals the square root of 8, and the square root of 8 is 2.82. Now, once again, we need to round here. The 2 is going to cause my 8 to stay exactly the same. So my d is equals to 2.8, or the distance is equals to 2.8. Lastly, our final problem, number 19. Here we go. So, my distance is equals to the square root of x2, which is negative 4, minus x1, which is 2. And I put a squared next to it. So I got negative 4 minus 2 squared. Plus the difference of y. So I have 1 minus negative 11, because 1 is my y2, and the negative 11 is my y1. And that is also squared. Next, I get distance is equals to this big square root. Negative 4 minus 2 is negative 6. And I'm going to keep that in parentheses. And then 1 minus negative 11. That minus a negative is going to create a positive there. So I actually have 12 squared. Now, I have distance is equals to the square root of negative 6 in parentheses squared, which is negative 6 times negative 6, which happens to give me positive 36. And 12 squared, or 12 times 12, is 144. So here, I'm going to get d is equals to the square root. When I add those two numbers together, we get 180. Lastly, 180 squared rooted, square rooted is 13.41, and we're rounding, so we're going to keep this 4 the same, so d equals 13.4, and that is it. that is your review. If you have any questions at all, please leave me a comment, send me a message, rewatch any portion of this that you need to. Thank you so very much for watching. This has been Mrs. Ross Does Math.